Good morning, class. Today we're going to cover one of the fundamental force of the universe, that is gravity. But before I begin my lesson, I would like to remind you to put your phone in vibration mode. Let me do mine first so that we do not interrupt the lesson. So let's start. We're going to talk about gravity, one of the fundamental force of universe. Today is main 9 and topic Okay. So there are 4 fundamental forces in universe. What are they? Number 1, we have gravity. Who are the pioneers of gravity? It starts from all the way Aristotle, and then Galileo, Newton, and Einstein. What is the number 2 force of the universe? Is electromagnetic force, and the pioneer of electromagnetic force is Michael Faraday and James Clerk Maxwell. Number 3 fundamental force of the universe is strong nuclear force, and Albert Einstein famous equation E equal mc squared that gives us the secret of the star. That's the strong fundamental force of the universe. And the last one is weak fundamental force of the universe. And people that came out with this idea are like Fermi, Abdus Salam. So let me write it down. Fundamental force of universe. As I said, the pioneers of gravity are Aristotle, Galileo, Newton, and Einstein. Number 2 force of the universe is electromagnetism. Magnetic force, and Faraday and Maxwell. Number 3 fundamental force of the universe is strong nuclear force. And Einstein. And number 4 is weak nuclear force. And people who contributed discovering weak nuclear force among Fermi, Abdus Salam. Today our main focus is gonna be narrow down to gravity. Next time we're going to pick up electromagnetism, strong nuclear force, and weak nuclear force. But today our focus is going to be on gravity. We're going to understand gravity. We're going to develop some kind of algorithm to solve the gravitational problem. Why we want to do it in gravity? Because it is the most mysterious force. Although scientists discovered gravity fast, but it is still the most mysterious force in the universe, simply because we don't understand it. Newton gravitational formula G times m1 times m2 over r squared and Einstein field equation, they break down at some point, and then we are helpless, clueless. So this is the most mysterious force of the universe. On top of it, this is still classical force. What I mean by classical force, I mean by classical force that this is still continuous force. On the other hand, this one is discrete. It's come as a package, is a whole number. You can describe as 1 or 2 or 3, 1 packet or 2 packet. And this one is just like discrete. This is also a discrete force, but this is still remain the continuous force. So let's begin our understanding by covering this topic, gravity, and let's do it from beginning, from all the way Aristotle, because understanding what those big giant thought about this thing is important to understand the force, because if you don't understand that, we will not be able to step into the next step. So let's do that. So it all started with Aristotle. Aristotle was born in 384 and 322 BC. So Aristotle gave us like 5 hypotheses. Let's list his hypothesis. Number 1, he said that falling object, the heavy object fall faster than the light object. Number 2, he said that the object fall toward the earth because they want to yearn with the earth. Number 3, he said that object in motion slow down because object get tired. Number four, he said object fall with constant velocity. And then he famously said that Earth is the center of the universe, who is led to the modeling of geocentric model of the universe. So he said that Earth is in the center universe that lead the path of geocentric model of the universe. Okay, then who come next? Then Galileo come next.